I'm Mike Williams. This is Team 15, Notorious CAD. We've developed a system to help reduce labor associated with motor vehicle accidents. We think this is an important problem to tackle because not only do automobile accidents cost cities and states money, but first responders must perform menial tasks that could be performed by robots. The direct customers of the system are state departments of transportation or city and county purchasing divisions. The indirect customers are motorists involved in or affected by accidents and emergency service workers. A few of the main design requirements for our system were the ability to warn approaching drivers of the hazard ahead, have the means to spray fire retardant on a fire, the ability to apply absorbent materials where a liquid has spilled, and it must have the means to clear the roadway of debris and absorbent material. We've designed 3 individual robots to accomplish these tasks: the traffic blocker robot, the fire suppressor robot, and the cleanup robot. So I designed the cleanup robot. It has tracks with gear motors to move around, a claw on an articulating arm to pick up debris. The claw and arm are moved by servos, and the claw has its own distance sensor. There's also a collection bin full sensor and a vacuum on-off servo. Then we have the circuit for the cleanup robot with the motors, the Arduino Uno, the sensors and servos, and the flowchart for the cleanup robot. It basically starts the vacuum, moves around, has options for different types of obstacles, checks if the collection bin is full, if an end signal is received, and if the entire crash site has been covered. And we have the full Arduino code for the cleanup robot. And starting the simulation for the cleanup robot. When the bin is empty, the sensor sees light, turns the vacuum on. When there is an obstacle within 5 inches of the claw sensor, the arms will move, the claw will close. As long as there are obstacles here. The claw opens and the arms go back to their starting positions. It also stops the gear motors for the tracks. And if one of the distance sensors on the sides sees an obstacle, it will reverse that track, make the robot turn, same for the other way. If both front distance sensors see an obstacle, it stops the right side of the tracks and reverses the left side, so it'll back away from the obstacle.
The firefighting robot is a tracked vehicle that moves to the accident, puts out a fire if one exists, then spreads oil-absorbent particulates around the area. It's equipped with a servo-aimable nozzle for dispensing chemical dry powder. The front and back have ultrasonic distance sensors, and there are 2 IR cameras for fire identification. From this back view of the vehicle, we can see the RF antenna mounted on top of the housing, the removable plate for accessing the interior of the vehicle, the trap door on the back for dispensing the absorbent particulates, and the other ultrasonic sensor to prevent it from backing up into anything. From the top-down view, with the lid removed, we can see the automatic solenoid valve for releasing the dry chemical powder, and the storage area for the particulate absorbent and the plate that pushes it out of the back. This view is in between the 2 tracks and underneath the dry chem kit cylinder and the particulate absorbent material. First we can see the 2 drive motors for the gears on either side, and then underneath those are 4 lithium-ion batteries. In front of that we have an Arduino board, and in front of that we have a tilt sensor. In this view of the track arrangement, we can see the drive gear that spins a large gear that drives the entire track, and in front of that we have a gear supported by a spring that absorbs shocks and also maintains tension in the track. In this last interior shot, you can see the mechanism used to push the particulate matter out of the trap door in the back. There's 2 lines of cogs along either side of the interior of the housing that are driven along by gears operated by a servo underneath. You can see that there's 2 gears on the left so that they can operate in reverse from the gear on the right. Here's a flowchart for the actions of the firefighting vehicle. It starts with a continuous collision avoidance loop that is running the entire time in the background just to make sure it doesn't crash into anybody walking around. Then it goes into a fire detection loop, which is its primary objective before deploying the oil absorbent material. So in the fire detection loop, it Basically, it starts out with does the left sensor detect a fire? If no, it sees if the right sensor detects a fire. If the right sensor does detect a fire, then it's going to turn right towards that right sensor until we can confirm that both of them see the fire. If neither can detect a fire, it's going to continue on its normal route, moving forward and searching for it. Once it finds the fire in both detectors, then it's going to deploy its fire suppressant and move on to the next loop. The next loop is oil absorbent deployment. First, what it does is it finds the GPS position of the vehicle. It determines if the ground is level around the vehicle or not. If the ground is level, it starts to dump the oil absorbent all around in a circle around the vehicle. If it finds that the ground is tilted, it drives around the vehicle to find the lower side and then dumps oil absorbent around the lower side. After it's finished these tasks, it returns to the starting position to be collected. This is a Tinkercad simulation of the circuitry in the firefighting robot. Up here on the upper left, you can see the two ultrasonic sensors for helping the robot with collision avoidance. On the bottom left, you can see two temperature sensors, and those I'm using in place of the IR cameras that would be used in a final design. Then right up the top in the center, there's two tilt sensors to help determine the tilt. These tilt sensors are going to be mounted 45 degrees apart, and I'll talk about that a little bit later. Just below that, you can see a controller for the two DC motors that control the drive of the engine, drive of the motor, drive of the vehicle forward and aft. And then over on the breadboard on the right, you can see the aiming servo up top, and underneath that is another DC motor that will drive the gear system that pushes all of the oil absorbent out the back. All of the functions I wrote for the sensors are int functions that return whatever value is pertinent.
Hello, my name is Ashton Sunderland. I'm going to be telling you about the traffic blocking robot. This is a robot that will be receiving a signal from the beanbags that are thrown down by the first responder. One beanbag will show the origin in which the traffic blocking robot will be approaching, and then the other will show the direction of which the right angle will face. Using mathematics, the robot will communicate to the other robots the outer edge of the top and side of the accident, so that the other robots know to stay behind and to stay outside of the other side of traffic on the other side. You can see in the first couple pictures here of the robot that you've got basically like a traffic sign kind of design in the front. That's to alert traffic from a distance. You can see four reflective circles on the front of the design, and that's just to catch the light of the headlights. Then you'll see some recesses inside where that's where the sensors are located. And then on the transparent slides, you can see more what's inside the robot. You have four electric motors, which are powering the treads to the robot. You have a battery. You've got the Arduino unit, which is in purple. Then you've got your transmitter and receiver in the back there, that's in orange and blue. And then if you look at the circuit here, the circuit connects, it's just a really simple circuit here, just connecting the ultrasonic motion sensors, which is in three different directions, front, side, and side. And the signal will go for two motors at a time, basically two motors, the two side, on each side are going to have the same signal. And then that's why it's for high, low would be forward, and reverse would be the opposite. Then if we look at the flow chart, basically it's a basic movement here. This is, it starts out by saying that it's going to initialize the pins. And then after initializing the pins, it's going to check to see if the distance in front of the robot is within 5 meters. If it's not, then it can move forward. Otherwise, it's going to check the distance to the left. If it's not within 5 meters, meaning that there's space, it's going to move left. Then if there's something in front and to the left of the robot, then it's going to check to the right. And if there's nothing to the right, it's going to move to the right. Otherwise, it's going to reverse, because that means that there's something on all sides. So just basic movement there. And here is the code for that. Basically, I've got it in here just to be able to move one whole side of the tread forward and move one whole side of the tread backwards to turn, to move them in sequence to move forward and backwards.
So this is a flow chart for how all of our robots are going to work together in the end, and it's the basis for how we made our MATLAB simulation. You can see that it starts out with 2 GPS locations being provided. They're provided by a user in the form of a user throwing 2 different beanbags to mark either side of a road that's going to be in question right before an accident. So you can see immediately after that happens, all 3 robots start up and begin to start their individual jobs. The traffic stopping robot makes its way over to stop traffic from coming. The firefighting robot begins to move towards a perpendicular line to start searching for the fire, and the cleaning robot immediately starts its cleaning pattern back and forth. So at this time, while the cleaning robot's looking for bits of trash and everything and debris to clean up during its pattern, it's also going to be looking for information about the damaged vehicle. If it finds anything, it's going to immediately send that information back to the firefighting robot. As the firefighting robot moves through with its task, puts out the fire, and then starts to spread oil absorbent on the downhill side of an accident, it'll record the position of the absorbent and relay it back to the cleanup robot so the cleanup robot can go forward and complete that. Once all of the robots are done with their tasks, then they return to the original starting position. Now let's look at the simulation for the MATLAB output that we used for this project. You can see on the lower left here, we've got the black asterisk, and that's the firefighting robot. The blue one is the cleanup robot, and the magenta one is the traffic stopping robot. Up on the upper left, you can see that green circle, which is one of the sandbags thrown by the original operator. You can see all the red circles, which are arbitrarily placed things to avoid so they don't crash into. It could be people walking around or debris on the roadway. And then the green square over on the right is the damaged vehicle in question. So let's start this and watch how it goes. Yep, you can see that the blue one started its path right away to start the cleanup process. The magenta one is the traffic stopping robot. It's stopped in the middle to stop traffic, and the black one is going and searching for the damaged car near the center line of the roadway. And there you can see that the black one just found it. It's putting out the fire and starting to spread particulate matter around the outside of the vehicle as the blue one continues going around cleaning up.
And as far as the entrepreneurial findings, this robot, all 3 robots, will, plus the cost of the beanbags and the parts for the robots, will be $960. Total labor cost $30, so we're looking at a total cost of $990, which is just under $1,000, which is perfect. So this is a brand new concept that's never been done before. The design adds a lot of value to our first responders' time, which is a precious commodity. And because there's nothing else out there, if you're somebody who sees first responder time as something that's really important, that's why you should invest, because it's certainly something that's precious. Thanks.
So in summary, our group of robots will help first responders and motorists involved in traffic accidents, and the concept of automating these tasks has not been implemented anywhere before. And we learned that it is difficult to automate anything involving multiple robots, and that to program these robots, you have to do it with a very high level of accuracy. And if we had something to do different, we would probably use a central hub to tell the robots where to go, and just use the sensors on the robots to avoid obstacles, since we didn't really figure out how to do that in the Arduino code, just in the MATLAB simulation. Thank you.